Okay. Hello. Welcome back. I have an example and then some tool that could be useful for you at this stage. Actually, please just simply search and you find the tool. But to properly introduce, we will have to learn on the topic of SPARQL, in which it is a query language that after you. The thing is that we have learned how to describe resources, objects, or instances using RDF, right? RDF graph, RDF XML, turtle, or corresponding syntax, whatever. After you describe the resources, after we have all these linked data available, after you and then move on to assignment 2, we are defining the schema, allowing you to describe more of similar resources too, right? And once all these things are available on the internet, on the web, or even used internally, the next thing is that you should be able to query, to do some processing, to query, to reason, to make use of the data you have. Not only you're having yourself, but it's in the form of connected graph or linked data graph. So SPARQL is the language that one of the language that we learn. How can we query all this data? So simply search for the word SPARQL Playground. You should be able to be accessed to get a link to access to this tool online. But we will find a way to run it locally as well. Okay, later on. Okay, you need to host the SPARQL Playground. You may want to try to find a way to download and install it on your own. Okay, actually, but that can be later. Because you want to run your own data with the Playground tool online, the data source that you can use for query and everything will be fixed. You cannot change. But later on, I want you to use your schema, use your data, load it, query it, and so on, right? So in that case, later on, you need to install a local host. On your local host, the SPARQL Playground. But as of now, we just use the online tool, which is fine. The thing is that if we go to the data, don't worry about the syntax because we need to learn. But if we go to the data tab, okay, this is an example of schema plus instance in turtle. So if you create everything in turtle, in which I encourage just turtle is fine, okay, because XML is too lengthy. So the very first thing you need to declare all the prefix, right? All the prefixes. Standard ones for sure. You need the line number 4 and 5 for RDF and RDF schema, because otherwise you cannot create anything in RDF and RDF schema definition. And the remaining, like number 1, 2, 3, 6, 7, 8, these are just kind of whether your RDF document would refer to some other standard existing namespace and vocabulary or not. So in this example, I think I can zoom a little bit. Okay, yes. In this example, what we can see is that it refers to DBO, DBpedia ontology, DBP, DBpedia property, and also DBpedia itself as the prefix for the DBpedia resource. Because we want to refer to existing one. All these number 1, 2, 3, they belong to DBpedia. Then 4 and 5, as I said, they are RDF. The order doesn't matter, right? TTO and TTR are in this example, vocabulary. And XFD is just the XML schema definition, right? because we want to later on use the XML schema data type. Okay. All right. What you can see in this example, I want to use this example to learn how to define class, subclasses, and properties, domain and range too, and later on define instances. So DBO person, the very first here, okay, I'm in this line. DBO person, these refer to existing person class defined already by DBpedia, not by us. Always you can use, you can link, you can refer, you can integrate existing classes defined by somewhere else too. But they must be available publicly, and they must be should be standard one or widely recognized one. Okay, so actually what is defined here is that anything starting from TTO. Actually the TTO stand for in this playground too by the author. They want to refer to the ontology. The ontology, actually, what we are defining, the RDF schema is kind of subset of ontology. So we call it ontology, which is fine. So this is tutor ontology, TTO. TTR, they want to make it to refer to the resource. That means describing the instances. So that's why they differentiate the two namespaces. You should, right, as we define the layer, resource or the schema part or ontology part are just to define the class, the property. You should use one namespace. Then the resource part or the instance part or layer, you can use another namespace. And this way, differentiate them, distinguish them could be a good practice, okay, to follow. Okay, back to this line number 10. TTO creator is supposed to be a new class defined here. And it said that person of DBpedia class, person is a subclass of this creator. It's like I want to define the very super class called creator in my ontology. And the person is a subclass, okay? And here you can see all this definition, but let me move to this one first, the creator here. Line 22. Why I cannot? Okay, anyway, line 22 here says that we want to define TTO creator as a class. And remember, I already mentioned that the annotation, okay, you should always make your schema readable, maintainable by providing sufficient annotation. It's like when you write a program and then you provide comments, right? This is the same way. So we are saying that this creator is defined by this our ontology tutor, and it has the label creator. Okay, back to some other line. Okay, I want to refer to this. Animal is the class. Okay, defined by label, fine. Then animal is a subclass of creator. Okay, you see here. Okay. Don't forget, use proper, something is RDFS. Okay, belong to RDFS namespace and so on. So now we have creator as the very top. Okay, you need to formulate in your mind, draw in your mind creator the very top. Animal as a subclass of creator. Also person, right? Defined here, person is also subclass of creator. We have person, we have animal. Okay, next we have cat here. Cat is under animal. Okay, with this, cat is a class and subclass of animal. Then what else? Dog. Here, dog Another subclass of animal. Here, monkey. Okay, what else? That's all. I think that's all for the classes. Animal, cat, dog, monkey, right? If you try to draw some hierarchy, I think this is straightforward. So what's next in this example? Pet is a property. Okay, here, pet. We have a property pet such that what? What does it mean? A person, pet, and animal. Domain is a person, pet, and then animal as range. Notice the way, the good practice to define a class and property. Normally, convention is that class should start with capital letter. Property start with small case. This is convention in object-oriented, always. And that allow us to differentiate, when you see the syntax, you can, if those who design properly follow this guideline convention, you can easily interpret the meaning, right? Okay. So here is the pet thing. It has a label, so you could see here the label is different. Pet has the label domestic animal. So when it shows for reading purpose, it will not say pet, but it will say a domestic animal. Anyway, this is just example. What else? TTO sex is another property. You see, starting with small case. Domain is creator has a sex, which is a string. Okay, this is literal property. Next, of course, is very simple. We have weight. Weight is a property. You see, now we have the comment weight in kilograms. So why this is important? Because if you see the weight property in Thailand and Asia, many countries, do you use kilogram in your country? Yes. But if you go to the US, maybe, or some other, they use pound, they use some different units, right? So the comment will explain how to use this property. Should be in kilograms. Okay. So creator has the weight property, which is the decimal data type. Okay, that's finished for the schema part. I think up to now, line 53, these are the schema. Next, you can, from 55 downward, they are all the instance description now. We are saying that we are referring to an existing resource available in DBpedia. DBpedia resource, Harrison Ford. You know Harrison Ford? He's pretty old. I mean, in my time, okay. I'm not sure in your time, you know him or not. Do you know? No, Rambo doesn't. Do you know him? Okay. He's I think Hollywood star, okay, actor. But yes, when I was very young, he's still young too. But now I'm getting older, he's getting older too. Okay, anyway, we are saying that Harrison Ford, this is a statement. Remember, subject, predicate, object, right? So we are saying that Harrison Ford, pet, snuff monkey. These are all instance. Harrison Ford is supposed to be an instance. Pet is a predicate property. Snuff monkey is supposed to be another instance, right? You see, even for the instance or object, we use capital letter to start with as well. That's fine. Object class with capital letter, but property start with small case. Okay, then we know that one statement, Harrison Ford, pet, snuff monkey. But snuff monkey is a resource in our data set now because it starts with TTR. Okay. Then now, oh, I should go. What is Snuff Monkey? Okay. Statement line 81 here. You can see we are explaining Snuff Monkey. Snuff Monkey is just the URI, right? The long URI, I think you can write with TTR prefix. Then Snuff Monkey, it has the name. With the name, we use DBpedia property defined by DBpedia. We are not defining everything. If we can reuse, reuse. Its name is Snuff. It has the color. It has the sex. It has the weight defined here. And it is a monkey. So this is a resource with the type monkey. Okay. And what else? Okay. Everything here, sex, weight. Yes, color. Where is the color property? Do we skip color somewhere? I think color is forgotten to be defined. Yes, I could not find color property definition. But that should not be difficult. Okay. So I think you can follow this and you can read what is explained here in this example, right? We have even like William is the parent of John. It has birth date, it has this and that, and we can actually combine our vocabulary with existing vocabulary defined somewhere else as a standard and want to reuse as well. Okay, this give a good example of defining new ones and integrating and reusing existing ones. Okay, any questions so far on this? Yes. Yes. So in the other website, I am referring to, you can search for a so-called RDF Playground. Okay. And okay, it should give you here. It will start from this page. But I already copy and paste from the SPARQL Playground, the data part, the turtle. The turtle statements, you can copy and paste here on this side. Click on the graph. Then you can visualize, oops, the full screen. Where am I? Browsing down. Oh, yes. Thank you. So if you browse, paste and click on the graph, thank you, Siri. Then you can see the generated graph corresponding to RDF, of course. It looks messy, definitely. But, and also one good thing is that it makes use of the prefix, in which it's not that very long URL, URI in the W3C, but it does not sort in a way. Okay, it's kind of visualized, but you can move in order to sort a little bit, but not that much. Anyway, you could see what is defined. Everything here is only based on what is defined in the turtle. It doesn't go and get DBpedia ontology and browse it for you, okay? Just only the text that you copy and paste on. Okay. If you define domain range, it will be there. If you define there is also the comment. Let me see whether it has omitted something. I think the comment and some of the annotation is not here that much. Do we have it? Annotation for, wait, okay, let's see. It should be there, everything. I don't think that it tends to. wait. Wait. Last person. TTO wait. Here. Yes, here is the wait. Okay, it has the comment and everything defined by the other example. I think, yes. Okay, anyway, so this is good. It is not the whole thing that should be useful to you, but at least it validates the syntax for you too. If you make a correct turtle statement writing, it should be able to visualize it at least. Correct syntax doesn't mean correct semantics, right? Okay. Oh, SPARQL is a query language. Turtle is just a syntax to write your statements. To write statement, right? Subject, predicate, object, that's it. But SPARQL is a query language that you can find persons who pet a cat, maybe. You will need to work on this, don't worry. We will learn this. And actually, these are the things you would do with SPARQL, for example. Find person and their pet. Get Harrison's Ford pet and birth date. Birthday. Select person with the birth date and calculate age and so on. So we'll do this is done by SPARQL, but Turtle is just to describe, right? To describe result. Harrison Ford pet, Snuff monkey, Luna cat. Luna is the cat. It has this weight. It has this and that. That is Turtle or RDF statement. Query is another thing. Okay. Query is by SPARQL. Explaining is by RDF graph and statements. Okay. Anything else you have in terms of the questions so far for this? So I would suggest, okay, try to write your SPARQL, your turtle, your schema, okay. First, make a design. Design is one thing, okay. Start with good design, understanding the design you want to create. This class, this class, this class. You think that you should have these properties for describing your example, right? Your object. So what are the properties? What are the domain? What are the range and so on? Then after you get this idea, writing the code in Turtle, maybe you draw, you draft, you sketch, fine, but then make the design in Turtle and validate one small pieces, small part at a time, right? You incremental development. You start with one class, one property, add more class, add more property, and so on. Do it. Okay. Tomorrow, we still have some time. I think we might, let's see whether you get stuck with something or not. Okay. Tomorrow, we might have some kind of consultant time as well. If you, it is good. I want to hear your presentation. Okay, if you can make it, present it tomorrow, and then we can do kind of consulting and allow you to do some revision if there's still some issues. Designing is it requires some practice and requires some experience. One thing that I usually found as a problem, let me bring something. Okay. Okay, suppose that we have defined these 4 classes, okay, A, B, C, D. First, of course, it can be that they are independent, they're not related. The way that you relate class do we need to run? Alien attack. Okay, the way to relate class could be that through subclass of, okay, so it could be that class B and class C are subclasses of class A. This is fine. Oh, one small thing. They are case sensitive. The syntax, the description, when you use capital C, capital P, small c, A, B, they are different. The class, when you define class, when you refer to RDF, because it's finally it refer back to URI, right? When it is URI, small case, capital case, they are different. So every time you write something, they make sure that you pay attention on the cases. Okay. All right. Okay. Yeah, I want to say here, this messy now. So B and C are subclasses of class A. This is one way to make class relationship. But the meaning, when something is a subclass of, meaning that any object or instance of class C, for example, will be object or instances of its superclass. So actually, if you use subclass, it means the instances of the subclass will be instance of the superclass. This is by meaning. And this is common meaning in object-oriented paradigm. For example, I think we can use biology, right? It's like in our TTO example, I think you have creator. Under creator, we have event person. Then we have animal. Under animal, we have cat, dog, monkey. Right? Remember this? If I have an instance, oh, should not be this. Okay. What did I do wrong? Okay. Something is not good now. Okay, I try to move slowly, sorry. All right, if I have an instant monkey, how can I draw a monkey? Sorry, I'm very bad at drawing. It looks like a mouse now. Okay, sorry. But anyway, remember we have snuff monkey. Snuff monkey. This is for sure. This is instant. Not a class, right? Snuff monkey is a monkey. It's an instant. Is snuff monkey an animal? Yes. Is snuff monkey a creature? Yes. And actually, later on, everything, oops. No. Everything will have to be defined under thing. So snuff monkey is also a kind of thing in our ontology way of conceptualizing. Okay, so this you must be careful. I think we need to change something. One moment. Okay, let's try with this. Better now. Okay, then every time when you want to model something using subclass of, test the correctness, accuracy of your design, okay, by trying that every object of that subclass, is it correct to consider it as an object of the superclass? If it is so, then that subclass modeling is somehow accurate, okay? Because I found so many mistakes in using subclass of as a design. If you have a class D, you may relate class D and class B not through subclass of, but through some property. Define a property to relate, such as, remember, on, pets, parents, parent of, child of, that's fine. Supervise, like faculty supervise the student, you can define property to relate them. This is called kind of association or relationship, way of associating class, one class with another. Okay. Common mistake I found is first, the subclass of. When things are not really subclass of, but sometimes you feel that they have some relationship or they are related in the same domain, story, application, conceptualization. You tend to use subclass for many things, okay? Try to validate this first. One example, I used to see that we could have like vehicle, then we could have like car, and actually you can have ship, you can have boat or something, right? There's a class wheel. Sometimes I saw somebody model wheel as a subclass of car. Can we? Is wheel a car? If wheel is a subclass of car, it would mean that you are saying there must be a wheel that is a car, right? No, wheel is part of a car or components of a car, or a car has a wheel, that's fine. But a wheel cannot be a car, something like this, but I used to see sometimes, okay? So be sure. Common mistake. Be careful. Okay, it's a subclass or superclass relationship. That's the thing. Validate your model by just saying that, by just testing it, that every object of the subclass, is it an object of the superclass? Maybe you can test it by using is wheel a car? No. If you say no, then it's not a superclass of class relationship. Is monkey an animal? Yes, then it can be a subclass relationship, right? Is every person a creator? Okay, yes. Okay. All right, I think that's more or less what I would like to emphasize. I give you the time. I think you may need to have some time to work, okay? So any questions so far?